Welcome to Want to Learn Chemistry, a site to help you become a chemistry expert. Today, you'll be learning about aluminium and titanium. Today, you'll be learning about the metals aluminium and titanium. What are their useful properties? How are they extracted from the ore? And what are they used for? Starter activity. Brainstorm what kind of design features do bikes need to be able to do tricks, and suggest materials the bikes could be made from. Today's objective: describe the physical properties of aluminium and titanium, which is at grade D. Give 3 examples of the uses of aluminium and titanium at grade C, and explain the method of extracting aluminium and titanium and why it is expensive at grade B. We know that metals are very strong, and many metals are also very dense. This means that we cannot use them if we wanted to make something that has to be both strong and light. Brainstorm the properties of aluminium that you might already know. Now let's go over some of the properties. Aluminium is shiny, it does not corrode easily, has low density, silver. It's a good conductor of electricity and energy. It can be shaped easily. Aluminium is relatively reactive, but it does not corrode easily. Aluminium atoms at its surface react with oxygen in the air. They form a thin layer of aluminium oxide. This layer stops any further corrosion taking place. Aluminium can be used to form alloys. These alloys are harder, more rigid, and stronger than pure aluminium. Because of these properties, we can make products such as cooking tools, drinking cans, high voltage electricity cables, airplanes and space vehicles, and many more. This is an example of only airplane and bicycle. Metals which are strong, have low density, and do not corrode are mostly chosen for these examples. And these metals are aluminium and titanium. Now let's answer some questions to check your understanding. A. Why does aluminium resist corrosion? And B. How do we make aluminium stronger? Now let's go over the answer. The reason why aluminium does resist corrosion is because it has a layer of aluminium oxide over its surface that prevents corrosion. And we can make aluminium stronger by alloying it with other elements. How do we extract aluminium? Carbon cannot be used to displace it from its oxide. Aluminium is extracted using electrolysis. During electrolysis, an electric current is passed through molten aluminium oxide at high temperatures to break it down. Aluminium ore must be mined. Ore contains aluminium oxide mixed with impurities. Aluminium oxide is separated from the impurities. Oxide is melted before electrolysis can take place. Electrolysis is an expensive process because high temperature is needed to melt the metal compound, and lots of electricity is needed to extract the metal from its molten compound. Also, you need to consider the environmental issues when using so much energy. Task: Tracy is 15 years old. Her ambition is to enter the Red Bull Joyride when she turns 18, but she needs a bike to train with. She doesn't have a lot of money and needs help from her parents. She goes to the specialist bike shop, and there are 3 bikes, one made of steel, one made of aluminium, and one made of titanium. Your task is to look at the fact cards on the next slide for each bike and arrange the cards into 3 groups. Consider the following questions. Which bike do you think she would want to get? Question 2. Why might she not be able to get this bike? 3. What are the differences between the physical properties of the 3 metals? 4. What are the differences in density between the three metals? 5. What are the differences between how the three metals are extracted? Make a note of these 5 questions, and this is worksheet with the properties. You need to look at the prices of these 3 bikes and the physical properties as well. Task 2. Answer the following questions on aluminium and titanium. Properties and uses of titanium. Titanium is a silvery white metal, strong and very resistant to corrosion. Like aluminium, it has an oxide layer on its surface that protects it. Not dense as other metals, but denser than aluminium. It has a high melting point and can be used at high temperatures. The uses of titanium. Bodies of high performance aircraft and racing bikes use titanium because its combination of strength and relatively low density. It's also used in parts of jet engines because it keeps its strength even at high temperatures. It's used in parts of nuclear reactions where it can stand up to high temperatures, and its tough oxide layer means that it can resist corrosion. And finally, used in replacement hip joints because of its low density, strength and resistance to corrosion. Extracting titanium. Titanium is not particularly reactive, so we can produce it by displacing it from its oxide with carbon. Carbon reacts with titanium metals, making it very brittle, so we have to use more reactive metals to displace titanium. Sodium or magnesium could be used, but both of them have to be extracted by electrolysis themselves in the first place. Before displacement of titanium can take place, titanium must be processed. This involves separating the titanium oxide and converting it to chloride. The chloride is distilled to purify it. Only then is it ready for the titanium to be displaced by the sodium or magnesium. Each of these steps take time and costs money. Answer these 2 questions to check your understanding. Question 1. What properties make titanium ideal to use in jet engines and nuclear reactions? Question 2. Why do we need electricity to make titanium or aluminium? Now let's go over the answer. Titanium is used in jet engines and nuclear reactions because it is unreactive, it's very strong, and it can withstand high temperatures. We need electricity to make titanium or aluminium because aluminium extraction requires electrolysis. The reactive metals magnesium or sodium used in the extraction of titanium were obtained by electrolysis. Now let's finish off with a short quiz. Question 1. Which metal is the strongest? Aluminium, titanium, or steel? And the answer is steel. Question 2. Which metal is the least dense? And the answer is aluminium. Which metal is the most resistant to corrosion? The answer is titanium. Which metal is extracted from its ore using electrolysis? And the answer is aluminium. Which metal is extracted from its ore using magnesium? The answer is titanium. Summary questions. Copy and complete using the words below. Question 2. Why is titanium used to make artificial hip joints? Question 3a. Explain the different reasons why carbon cannot be used to extract aluminium or titanium. And 3b. Name 2 processes in the extraction of aluminium that require large amounts of energy. Now let's go over the answers. You have been listening to me at Want to Learn Chemistry, a site to help you become a chemistry expert. Like and subscribe for more videos.